Okay. All right. So today we're gonna work some of these things, and we're gonna not use your calculator for a while. So you can use it just to put the graph in to see what it's gonna look like, but most of the graphs we're just gonna take apart and look at all the pieces. So we should be able to sketch and describe these things without your calculator. All right. So let's get to this. Excuse me. Thank you. Thank you. Thank you. All right. So we talked about this a little bit before. We talked about the highest exponent, what the highest exponent is going to show you. And I've been doing the highest exponent with you so that you get used to seeing that. The highest exponent tells you how many zeros, how many roots crosses the x-axis, or not cross the x-axis if they're imaginary. We're going to do two parts to this. We're going to do just the real roots, and then we'll deal with our imaginaries separately. So we're going to know how many roots this thing is going to have. Again, when you start with your n is going to tell you how many roots. N minus 1 is going to tell you how many turns. And then your turns keep on going. Minus 1 will tell you how many reflection points you have, inflection points you have. God bless you. It must be contagious in here. Inflection points. And an inflection we'll talk about. Did you ever use the word inflection?
No.
In the graph? No. Okay. All right, so we're going to start with this. When n is an even number, okay, like 2, 4, 6, 8, and you've been seeing these graphs already, your n behaviors behave in the same direction. The n behaviors either are going to go up or they're going to go down. Kind of think of a parabola with a square. So if they behave just like that, the graph touches a basic graph like this, will touch at the x-intercepts, those will be your roots. If it bounces off there, or if we're supposed to have two of these, and it bounces off the x-axis, that is called a double root. If it goes through the x-axis, then there's your two roots like this. So we're going to be dealing with that as well. What I want you to get from this part here is just the n behaviors. Where does your n's go? We do a lot with asymptotes too. So if it's even, our n's are going to behave the same. Either they're both going to go up or they're both going to go down. Okay. If it's odd, the n's behave differently. It's going to cross through the x-axis. It's going to cross somewhere through this, like a cube. Think of a cubing function. And we should see this come through. It'll make sense in a little bit as soon as we put the rest together. Here's where it falls like a little bit better. Your leading coefficient test. That's the coefficient in the front of this. So if I say 2x squared, this is positive. If this is positive versus negative 2x squared. So on a positive one, let's do the even one first. On a positive one, it's going to tell me both ends are going up. N behaviors. On a negative one, both ends fall down. This one's going down too. It just does not appear in there. On the odd ones, same kind of format, but your ends behave differently. Does anybody have Mr. Baker? Did he do his little dance, right? He does his Saturday Night Live dance. The ends go down when it's positive and up on the right when it's positive. Did he do that dance for you? It goes the opposite way when it's negative. Okay, so does it make sense? Okay, makes sense. So far that makes sense to you guys. All right, finding your zeros. Right now, we're looking for all your real zeros. What is the difference between me saying real are all zeros. The real ones are non-imaginary. So where am I going to find those real zeros? On the x-axis, right? I will find these on the x-axis. If I find them on the x-axis, what is the value of y? 0. So the first thing we're going to do, and we always solve all intercepts algebraically, that's not going to change. So we're going to set this equal to 0, and we're going to solve. This is going to tell us how many roots do we expect to find, our highest exponent? 4 roots. Where is my ends going? If my co-leading coefficient is positive, where are my ends going? Up. My ends behavior is up. Okay. And we should see this cross the x-axis, or give me 4 roots. If it bounces off, it's a double. So how should I start this? Factor out an x squared. Good. And then what's left? Okay, and now what? Factor again. Minus 5 plus 4. Good with you guys? Good. Now what? Set them equal to 0, just like you always did. Now, right here, this guy, technically, when you take the square root, you get a plus or a minus, right? This is your double root. The 2 of these, this is my double root, where x is equal to 0. Then x minus 5 is equal to 0, so x is equal to 5. And x plus 4 is equal to 0, so x is equal to negative 4. So how many roots do I have? 4. I still get 4. Okay, so when we look for your zeros, we're going to find your zeros through this. Now, if we were sketching this, kind of like based on, excuse me, based on what we have, I know the 0 is my double root. That means it's not going to pass through here. It's going to bounce off. Either I'm going to do this or I'm going to do this. I have a negative 4 and a positive 5. Where are my end behaviors? Up. So this guy's going up like this. Doesn't this have to cross through? And it just makes a W, right? I have to bounce off of this now. I have to bounce off of this. So somewhere I'm going to connect them, right? Now, this is not symmetric. So it's probably not going to be the same dip in both of these. I don't know where my dip is right now, so I'm just going to give myself a little hump there. They're probably not going to be the same because one's a 5, one's a 4. Okay, so I pretty much have a good idea what this graph is going to look like. I know a lot from this graph. So we know your end behaviors. Excuse me, we know how many roots we're getting, and we'll be able to tell where they are. Your domain you can get from these because you're all real numbers on the square ones, but your range you would have to figure out where your minimum is. That part I don't ask you to do right now. We can do that part on your calculator. As long as you kind of get what this is going to look like, and that one dip is going to be a little different than the other because it's not symmetric. If this was at negative 4 and this was at positive 4, and my ends went up here, and I'm going to bounce off, then I would expect these somewhere to have the same exact dip in them, because it would be symmetric across your y-axis. Okay? So these are kind of little subtle things that we look for. We can find your roots, and we always find your intercepts algebraically, and we know what a double root looks like. So now we're going to sketch and describe this thing, and we're going to talk a little bit about concavity after this. First, tell me this. 3 roots. Where's my ends going to behave? Opposite. So the left side is down, left side down, and the right side is up. Okay. How many turns should I have? 2 turns. How many inflection points should I have? Up. You're about to figure out what an inflection point is. Okay, now, how do I start? I got to find my roots because I know I need to go up and down, but I got to find out from where, right? So I set this guy equal to 0, find your roots. What should we factor out? So again, set them equal to 0. And what's up with this guy? He's a double root. So somewhere we're going to sketch this. And we're going to have the double root here. And somewhere we said 3/2, right? About the 3/2. So again, you're sketching, so just kind of go here with it. Give yourself enough space, because that's the only number we have out there. Now this is definitely, God bless you. This is definitely my end, my right side. It's my last root on that side. This guy's going up, right? So when it goes up, doesn't this pass through? This is my left side. Where's my left side going? Down. This is not going to pass through, right? Because it's a double root. It's got to bounce off now. So I know this has got to come back down here. So somewhere I must have looped. If you want to make your loop a little bit bigger, I should have made mine a little bit bigger because this is where we're going to talk about your inflection points. What's your domain for this guy? All real numbers. You okay? Range? Yep, that's what's nice about the cubing ones. Okay, now, concavity. Something we have an increasing, decreasing. If I'm doing increasing, decreasing, this is the point that I say I'm increasing to my x value, then I'm decreasing to this x value, then I'm increasing like this, right? Concavities work a little different. They make caves, like this. They kind of make a cave. Did I give you a definition on yours? No. Okay. They kind of make a cave. They're either going to cave down or they're going to cave up. So if I kind of look at this, I can see a little cave down here, right? See a cave down? And if I look at this, I also see a little cave up like this. A cave up. Somewhere over here, right there, they're overlapped. So what we do is we say, if I go halfway, that's called an inflection point. The halfway mark, excuse me, is where I was going through this and I decided to change. I was going down. I said, whoops, I think I'll go back up. And I switched at an inflection point. You might have talked about, did you do, in Algebra 2, did you do the normal curve? You did this. Did they talk about an inflection point at all? Okay. Okay, so no. All right, so an inflection point says I was caving down or up, and then I switched. But this is what helps us. I'm going to take 2 turns. I have 2 turns up here and down here. I should have 1 inflection point. So to find my inflection point, right now, all we really need is your x value. So we're going to take this root, and we're going to take this root, and we're going to come down here, and we're going to have to take a minimum down here. I'm going to have you put this on your calculator. We're going to take a minimum. We know this guy's the 0, 0, but we don't know what this one is. So for this guy, we're going to have to put it on your calculator, and we're going to have to find this point right here. Relative minimum. So if you kindly, someone throw it on their calculator. Just give me your relative minimum. I don't think I have it. God bless. I need to find this point right here. I know this point, I know this point, I need to know this point. This is my max right here at the 0, 0 because we took that root. But I don't know this point here. Because these overlap, I have to figure out what's the halfway mark between them. How do I find out a halfway mark, a midpoint? What's that? Point. Okay, hang on. But how do I find out a midpoint of something? X1 plus X2 divided by 2. I just take the average of the X's, the average of the Y's. Our average of the Y's are going to work a little bit differently, but our average of the X's are going to say what? So what was this point down here? 707? Thank you. So all I care, and do you have the Y value? Oh, okay.
I got 1 and negative 0.5.
1 and negative 0.5? The click minimum? Did you go through the curve? Maybe you missed the curve. Make sure those little arrow things that they put up there fall right where your minimum wants to be, because wherever those little arrow guys fall is the minimum spot that it will find. So when you tell it minimum, you got to make sure those arrows line up. Now, this is the point I'm concerned about. This 0 and this 1. So here's my graph over here. It's where I should have made it a little bit bigger. Here's my point. This is the 0, 0. This point is 1, negative 0.5. I care about this point in the middle. So I take the average of my x's. So 0 plus 1 divided by 2. Same thing that you did in geometry. So I get my x is equal to 1/2. Now, sometimes it works out the average of the y's, and in this case it's the 0, 0, it will, and sometimes it doesn't. So we go to your calculator. Go to your calculator and do second trace number 1 value and put in x is equal to 1/2. And 9 times out of 10, we're doing just very simple graphs. They work nicely, but sometimes they don't. So find me the y that's associated with this x value. Should say 1/2 what? Negative 0.25. This one is fine because it's at the 0 and the negative 0.5. We're pretty cool with that. There's nothing else going on in this graph. Now, my inflection point tells me this. I am caving down, making a downward cave, right? You know what a cave looks like? See those on scary movies when they go into those caves? It looks like a big opening like this. It caves down from negative infinity to this inflection point, to that x value. Then, this is a concave down. Then I changed my mind, and I concaved up. See the upward cave? It's kind of like just the cave is facing the other way. It kind of makes like a smile. I concave up from that point, the 1/2, to the rest of the way. Okay. So when we look for concavity, if we just did a normal parabola like this, I concave the whole time. I concave up, right? So from negative infinity to positive infinity, I concave up. Same as my domain. This guy, I have some turns in here. That's why we go through this. 3 roots, -1, 2 turns, -1, 1 inflection point. If we turn 4 times, then 4 roots, 3 turns, 2 inflection points. I can find them both. So this is a good thing to walk through when you're doing this. So I need to find the inflection point. I still, just like my increasing, decreasing, I go off my x value, but I look for my caves. Concave down, concave up. Make sense? That's a little bit different. We probably haven't done anything with concavities. Any questions? It takes a while to get into this. All we really added before, we still did your roots. We called them your x-intercepts. We're calling them your zeros because it's going to help us with your end behaviors. We're adding concavities in here where concaves up and down. Concavities get a little trickier when your grafts go like this. When they go like this. This is still considered a concave down. This is still, whoops, that was still considered a concave up. So for now, we're working regular grafts right now. And if you want to make your sketches just a little bit more exaggerated so that you can fit things in there, like if something is 1/2, stretch it out just a little bit because then you won't even be able to put a little line in between there. So just exaggerate them a little bit.